So the first question asks us to, well, the first 4 questions, they ask us to solve for x. So these are our quadratic equations. The last time that we would have learned these would have been in grade 11, at the beginning of our grade 11 year, most likely. But you've been solving quadratics in all sorts of different situations leading up to this point. So theoretically, we should know how to answer these questions. So don't be shy. I'm going to call on you guys. There's not a lot of people here. There's only 31 of us, well, actually 29 if you take Yolanda and I out of the equation. So don't be shy to offer answers. Nobody's going to judge you or laugh at you. There are no stupid questions. We really are just here to help you as much as possible. Okay, so when it comes to question number 1 in paper number 1, this is generally going to be out of, I haven't got all the questions that we would see here, but it's generally out of about 25 marks. The first 4 questions or so are always going to be solving for x. And then they're going to get you to solve simultaneously. And then they normally ask, after that's done, they normally ask a more difficult question on either nature of roots or exponents. Okay, so if those nature of roots or exponent questions are difficult, and they normally can be very challenging, we need to make sure that in this question we score the maximum number of marks possible. Okay, so if we have a look at question 1.1, what do you think you need to do in this question? You don't have to tell me what the answers are necessarily, but what do you think you need to do? So have a look at the question. It's just out of 2 marks, so that gives us a clue as well. What do we think we need to do in question 1.1? Okay, so Kalipa says get rid of the brackets. So Kalipa, when you get rid of the brackets, do you mean you should multiply out? Yes, okay. I'm so glad you said that. I really, really am, because this is something that a lot of students do, and it's actually not the right thing to do. So I'm so glad you said that, okay? Because now I can help you with this question, all right? The reason why you're not going to multiply out is because it's already factorized and it's equal to 0. Right, so remember, when we're trying to solve a quadratic equation, that's what we want. We want to get all the terms onto one side, we want to make it equal to 0, and then we want to factorize. And that's our last step before solving the equation. So in fact, to multiply out, to refactorize, is not the correct way to go about this particular question, all right? So here, it would simply be a case of writing down your answers. And I can see some people have put that. Okay, so Tristan and Kalipa, getting rid of the brackets, you're not going to do that with this question. Okay, you're not going to do that with this question. You've got a factor or something in terms of x, so half x times 2x minus 1 equals 0. Okay, so either a half x equals 0, or 2x minus 1 equals 0. Okay, so it's already factorized for us and equal to 0. All right, so if half x is equal to 0, if I multiply both sides by 2 or divide both sides by a half, it doesn't matter, because when I multiply or divide 0 by anything, my answer is going to be 0. On this side, I would take the 1 over, and now I'm going to divide both sides by 2. Okay, so that's why we would have 2 answers here. All right, so either x is going to be equal to 0, or x is going to be equal to a half. So the 2 marks that they are allocating for this question will be on the answers only, just like that. Okay, so check to see. Normally the first question is like that. If we have a look, I've got another question down here. Can you see this question is exactly the same? They've got something times a bracket is equal to 0. Okay, so different numbers, different something inside the bracket, but it's exactly the same idea. All right, it's already been factorized and it's equal to 0. So all you have to do is write down the solutions. No problem, Amahle. We're glad you could join us. We were just talking about question 1.1 and working out the solutions to that. We're going to start with question 1.2 now. All right, so typically speaking, you're having trouble logging in. Oh, goodness. Oh, well, I'm glad you got in here. All right. So typically in the second question of question 1 of paper 2, there will be a quadratic. Normally, it will be already in standard form equal to 0. And then they will tell you that they want the answer correct to 2 decimal places. Okay. So by telling you that they want it correct to 2 decimal places, what are they telling you to do without saying it? Oh, hang on a second. Yes, Tendai. Yes, Kalipa. That's perfect. Okay, Unati, I don't know why you got -1/2 as your answer. Remember, when you take that 1 over to the other side, it's got to change its sign. Okay, so here I took this -1 over to the right-hand side. Okay, and now over here on the right-hand side, it's +1. Okay, yes, you guys are 100% correct. So those of you that are putting into the chat that we've got to use the quadratic formula, that is 100% true. All right, now what is the rule when coming to work with a quadratic formula? What are you always expected to show? What are you expected to show when you use the quadratic formula? And this doesn't matter where in maths you use the quadratic formula. You've got to show this. What am I talking about? Let's look at what you guys are saying. Substitution, quite right. Absolutely. Formula and substitution. So Tendai is absolutely correct. Lebogang, if you want to write down the formula first, that's fine. Okay. But what you mustn't do is write down the formula and then pick up your calculator. All right. And then put the values into the calculator without writing it down. Okay, it's very important. Yes, Nolwazi, you have to show substitution into the quadratic formula. All right, always, 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 whenever you use it anywhere in maths, you've got to show that you have subbed in. Okay, so looking at this, we can see, all right, so negative b, so that would be -6. Plus or minus. And now, what do we always use when we substitute? And I know the matrics at my school didn't do this when they wrote our trials papers, and so many of them lost marks. What do we have to use when we substitute? Exactly. Good. Well done. Brackets. We have to use brackets, especially when we are substituting negative numbers, or if it's after a minus sign and it's a binomial, because, okay, and I'm just going to go back to this very quickly, and I'm sorry if I'm boring you and telling you stuff that you don't already know, but these are just also common things that we see happening all the time in maths. Let's say I have a negative number, so like -6, for example. If I substitute my -6 and I don't use brackets and then I square it, I get a very different answer to if I use brackets and then I square it. Okay, so the problem here ends up not with your value, but with the sign of your value. Okay, because on the left-hand side here, -6 squared means 6 times 6 times -1, or -1 times 6 times 6. So on the left-hand side here, the answer would be -36. Here on the right, it would be +36. That's why you've got to use brackets. Okay, because it's not, as I say, it's not the value, it's the sign of the value that's going to become a problem. And especially when we're using the quadratic formula, if you get a very negative answer over here, you're going to end up with negative roots, because whatever's going to be inside your root is going to end up being smaller than 0. Because remember, you are then taking a number, you're squaring it, and then you are subtracting 4ac. Okay, so if A and C, if one of them is positive, the number that you're going to end up subtracting is going to be smaller than 0, and you're going to end up with a negative root. Okay, and then on your calculator, when you put it in, it's going to give you a math error. All right, so very important, use brackets always for all substituting. So -6 squared minus 4 times A, the value of A in this case is 2, and the value of C is -1. And all of that is over 2A. All right, and you can see here it's out of 3 marks. Okay, so oh, I don't have my calculator. Hang on a second. It's a bit silly. Mind you, I suppose I could have called up my on-screen calculator, but anyway, never mind. Okay, so let's work out the answers to that. Sorry, guys, I should have been a little bit better organized. I was standing outside talking to my cat before I came in instead of getting myself ready. Okay, all right. So I don't know about you, but I'm getting 3,16 as my first solution. Let's see what you guys are getting. Okay, Mamelo, Tendai, okay, all right, so you're getting the same answers there. Let me just check my second answer. Yes, perfect. Okay, and what was really nice to see is that those of you that put answers into the chat, you also rounded perfectly to 2 decimal places. So something else you may not be aware of, but oh, good. So Tawfiq, I hope I said that your name correctly, and Guguletu, and Nhlanhla, cool. All right, well done, that's perfect. So I'm going to say what I'm going to say now. 1 mark for subbing in, that's why it's out of 3. 1 mark on this answer, another mark on that answer over there. This question, 1.2, is usually always where you would use your quadratic formula. And it is also the only question in both papers where they penalize you for rounding. Right, so be aware of that as well. So let's say with my second answer, it's actually -0,158. If I wrote -0,15, I would be penalized here. Okay, so just be aware of that. It's the only place where they penalize for rounding. So be very, very careful that you don't, or that you do round correctly to 2 decimal places. Okay, all right, cool. So those are really the straightforward questions over. The next couple of questions require a little bit more depth in terms of understanding, etc., etc. It's not just a straightforward substitution or writing down answers. We've actually now got to do a little bit of manipulating. Okay, so in question 1.3, I'm not going to tell you. I want you guys to tell me what is the method that we have to use to answer a question in 1.3. You just have to say the first couple of steps. What are we trying to do here? That's it, Nhlanhla. Good. Yes, Mamelo, we would end up transposing that positive too. But in Nhlanhla, that's really it. Okay, it's the squaring of both sides. It's a question that has a root in it. But yes, you guys, there we go. We need to isolate the root and then square it to cancel the root. Absolutely. What did Gugu say? Transpose, remove square root, factorize. Beautiful. So all of you are saying the correct thing. Okay. What is the other thing that you have to be aware of in this particular type of question? One where you end up squaring both sides. What do you need to be careful of? Can anyone remember? There's a big beware with this question. So Gugu says brackets, Nolwazi says the signs. And Michael says expanding the other side. I'm glad I asked this question. You're right about all those things, but what I'm specifically referring to, and I know this is probably, it's, you know, you can't read my mind or anything. The 2 is not in the root. Yes, that is something that you have to be careful of, Mamela, because you've got to take it over to the other side. But what I was trying to get at here, Matrix, and so many people forget this, all right, is that with this specific question, where you end up having to square both sides, what you've got to be careful of is that because you squared both sides, you may, and I use the word may, and I'm trying to emphasize the word may, have introduced a root that is not valid. So in this question where you've got to square both sides, you've got to check your answer at the end. Do you remember this? You've got to go back and go and sub in and say, does the left-hand side equal the right-hand side for this value of X? Do you remember that? Is it ringing a bell now? Okay, so Gugu says yes and Hlantla says yes. All right, so with this question specifically, you've got to go back and check, because by squaring both sides, you may, and I may, you may not have. So what can happen with this question is that you square both sides and you could find that both roots are valid solutions. Or you could find, most typically, is that one root is a valid solution and the other one is not. And the reason that they like to do it like that is because they want to test that specific concept. Did you remember to go back and check? So often, it's a case of one root is valid and the other one is not. Okay, but they can both be valid. They can both be valid roots. One can be valid and the other one is not. And in some rare situations, both roots are actually invalid. But I don't think that that would be a likely situation. I think the most likely scenario would be that one root is valid and the other one is not. And I'll show you how they mark it when that situation arises, as it's going to in this particular case. All right, so we're going to do what a lot of you suggested. We're first going to transpose that 2 over to the other side. So that means that on the left, we've now got x minus 2. And on the right-hand side, we've got our root with our 2x minus 1 inside. Okay, so the first step, correct, moving the 2 over. And that is because I think it was Amahle who said this, you want to isolate the surd. You want it on its own with no additional terms on one side of the equal sign. And now, once you have isolated the surd, you are going to square both sides. Again, another place where matrics often lose marks is with the squaring of a binomial. Remember, when you square a binomial, you are not simply just squaring the first term and squaring the second term inside the brackets. Remember, it means x minus 2 times x minus 2. So there has to be a middle term. Okay, so if I write down, let me just change my pen color. So if I write down x squared minus 4x plus 4, is everybody happy with where that comes from? You know why it's x squared minus 4x plus 4. Yes. Okay. All right. Okay, cool. All right, so don't fall into that trap either. And of course, when we square a square root, it means there is no more square root. So that's simply going to be good in Mbalendle. It's simply going to be that. Now, because it is quadratic, same good Unati. Same rules as always, get everything onto the left-hand side and make it equal to 0. So this is now going to become minus 6x, and here it's going to be plus 5 equals 0. Okay, so I have transposed the 2x and the minus 1. Okay, And now it's in standard form. Now I've got to do the same old usual thing. I've got to factorize, or if my factorizing is difficult, I've got to do the quadratic formula. I'm hoping that for this would be easy enough for you guys to factorize, because the middle term, the x term, is negative and the last term is positive. Oh, there we go. Mamelo's got answers already. Well done, Mamelo. Okay, so inside both brackets, we will have negatives. All right, so either x is equal to 1 or x is equal to 5. And this is what we have to go back and check. So I think what I'm going to do now is just give me a second. Sorry, I should have thought of this before the time. I'm just going to call that up there. And then I think I need to do a new share so that you guys can see my calculator. Okay, so I'm just doing this in case you are struggling to understand what I mean, because I know my class battled with this again when we it's not compulsory at all. It's not compulsory at all. So if you want to use the quadratic formula, you can. If you want to factorize, you can. The only rule is, in Nhlanhla, if you use the quadratic formula, you've got to show that you've subbed into it, because you subbing into the quadratic formula is the same mark that you would get on this line over here where you showed your factors. So instead of showing your factors, you've showed that you've subbed into the quadratic formula. Okay, that's the deal. Okay, so now can you see here, if we go back to, now we're looking at our original equation. I know, Mamelo, you've already answered this, and I'm sorry if I'm boring anybody. I'm just trying to be thorough. We've solved x. So if we go back to our original equation, we're looking at it from a left-hand side, right-hand side point of view. So on the left-hand side, we've simply got x. So let's consider our answer of 1 first of all. All right. If I now sub 1 into the right-hand side, I'd have my root, and then I'd have 2 times 1, because I'm saying x is equal to 1 in this case, minus 1. Now I want to come out of my root, and then I want to add 2. Now it needs to equal 1. Okay, because remember on the left-hand side, I had x, and I'm saying x is equal to 1. So 1 does not equal 3. That's why, I don't know if you guys saw, Mamelo put in the chat already, that this is not a valid solution. All right, so we would simply cross out the equal sign, or you could write NA, or you could write not a valid solution. All of those things would be acceptable. X cannot equal 1, quite right. Okay. Then for 5, we know we've got 5 on the left-hand side. So when we sub into the 5 into the right-hand side, do we get 5? So let's just check. So we've got 2 times 5 minus 1. And now we're going to come out of our root and we're going to add 2. And if we get an answer of 5, it is valid. There we go. Okay, so 1 is invalid and 5 is valid. Now, normally what they do is, oh, sorry, before I carry on, is everybody okay with that? Are there any questions on this process where we have to go and sub in again afterwards to go and check our answers? Okay, you're all saying yes here. All right, lovely. No, Tenda, you don't have to show that. You don't have to show that you checked your answers on the page. That's something that you're allowed to just do on the calculator. And then you can eliminate the answer that is not, if there is one. Okay. All right, perfect. Okay, so I'm going to get rid of my calculator for now. So the 5 marks that it's out of, right? And the last line is not the most important, but very important. Okay, so where are we going to get marks? We're going to get a mark for squaring both sides. We're going to get a mark for putting it into standard form. And in this particular paper, although not all papers will be like this, sometimes if this question is out of 4, which it can be, the last mark over here is for both answers, for disregarding 1 and accepting 5. All right. In this particular case, they were nice. They gave you another mark like that. Okay. What you mustn't do is scratch that answer out. Okay. So don't do this. Don't do that where you scratch that out and you've only got this answer. Right, because you're going to be penalized for that as well. If something is an invalid answer, all right, then write there not applicable, okay, or put a line through the equal sign, but do not scratch the answer out, okay, because if it's out of 4 marks, that 1 mark will be for disregarding 1 and accepting 5. Okay. All right, cool. If there are not any further questions on that one, we can go and have a look at question 1.4, which a lot of people struggle to answer or understand what the question is actually asking us. So this is a quadratic inequality. Okay, quadratic inequalities are not the same as quadratic equations. All right. On the left-hand side of the equation is a function. It's a parabola, 2x squared plus x minus 15. And if you are going to draw that parabola, you know that is it happy face or sad face? It's happy face, absolutely. So it looks something happy face. Cool. Well done, everybody. It looks something like that. Now, it will have, whoopsie, that's a very wonky x-axis, but there's my x-axis, right? And your parabola is going through the x-axis, right? And the idea is this, right? Either they want you to solve for those values of x where y is negative, or they want you to solve for those values of x where y is positive. So the idea here is that you have y equals 2x squared plus x minus 15. Okay, that's the parabola that's been sketched. So when they ask you to solve for x, they want to know for which values of x is y positive or for which values of x is y negative. Now, which is it in this case? Are we looking where y is positive or are we looking where y is negative in question 1.4? Indeed, where y is negative. Good, absolutely. Okay, because essentially we've got y, which in this case is 2x squared plus x minus 15, is smaller than or equal to 0. Absolutely. Well done. And y is going to be negative. So think about our Cartesian plane. Y is negative. Your y values are negative below the x-axis. That's where y is negative. If the sign was changed around and it was like that, then we would be looking over here or we would be looking over there. Okay, but we can talk about one like that if you want to after this. Or maybe we could use the same question and just do the solution if it was greater than or equal to 0. Okay, so our first step in a question like this is if it's not in standard form, get it into standard form. So that means all the terms are on the left-hand side and you've got your inequality sign there. Your next step is to factorize. What is the purpose of factorizing? What does the factorizing do in this particular case? Okay, and what are those? Yes, quite right. So yes, there we go. So what are these x-intercepts called under these circumstances? There's a special name for them. Yes, your critical values, absolutely. Now, I just want to go back. Amatle, can we not use the quadratic? Do you mean the quadratic formula? I'm so glad you guys are asking this. Can you use the quadratic formula in this case? All right. The problem with using the quadratic formula here is the fact that when you use the quadratic formula, you are temporarily ignoring the fact that this is a quadratic inequality and not, you're ignoring the fact that it's a quadratic inequality. You're treating it like it is a quadratic equation. All right, and that is the problem in this particular case. So this is one question where we are not supposed to use the quadratic formula. We are supposed to be able to factorize this. Now, what you could do, I suppose, even though strictly speaking, it's not technically correct, is somewhere here on the right-hand side, you could solve, but the problem is you're still going to need to take your solution and put it back into the brackets. Okay, so I suppose it's not really the right thing to do, but let's say over here, let's say I decide to call this rough work and afterwards I cross it out. So I go x equals -1 plus or minus, and then I'm going to have b squared minus 4ac all over 2a. All right, so when I do that, I'm going to end up with my x-intercepts, obviously. So in this case, it's going to be, so let's just put in this into the quadratic formula. So now on your calculators, in fact, you know what I should do? Let me do it on here. Okay, so you've got, just pop this over there. Okay, so you've got -1, and let's go plus first. And then you've got your root, and inside your root, you've got 1 squared minus 4 times 2 times -15. And then at the bottom, you've got 2, oopsie, at the bottom, hang on a second, there we go, 2 times 2. So you've got 5 over 2, right? What you can then do, so that's 5 over 2, and then here, if we then went back up here, oh, sorry. Ah, man, I had it. I think it's gone now. Oh, rats. Okay, my second solution would be -3. What you could do is that you could use your answers on the side and work backwards into these brackets. To get an answer of 5 over 2, your 5 has to be inside this bracket and the sign has to be the opposite. If you've got an answer of -3, then inside this bracket over here, you have to have +3 like so. Does that make sense to everybody? Okay, so if you really struggle to factorize and it's a massive problem for you, write on the side that this is rough work. Do this as I've shown you over here and then go backwards. Okay, because what we can do now is we can put a line through that and nobody can mark us down. And then at least, does this make a bit more sense now? Okay. All right. Oh, I'm so glad, Amatle. All I want to do is just help you guys. Right. So there we go. All right. And now we can say, okay, our critical values, and we have to use the words critical values. Okay, so often what happens in these sorts of questions is that students just write, okay, x equals 5/2 or x equals -3, and then they move on. Okay, we haven't actually answered the question. What we have done is we have found the x-intercepts, and the x-intercepts are critical because these are the values at which y changes sign. Okay, from being positive to being negative, or from being negative to being positive. Okay, now that you've got your two solutions, the smaller one goes on the left, the bigger one goes on the right, because we're working with a, you can do that, absolutely. Yeah, so if you get an answer, Tendai, let's say you get an answer of 3/5. If they tell you that x is equal to 3/5, then inside your bracket, working backwards, the 5 was the coefficient of the x, and it was a -3. So just think about if you had two brackets, like let's say over here you had 2x plus 1, and it was equal to 0. So just like what we were doing in the beginning, all right? If you're going to take 5x minus 3 and make it equal to 0, the 3 is going to become positive. You're going to divide by the 5. Okay, so what's in the denominator is the coefficient of the x. The number in the numerator is the second term in the bracket. You've got to change the sign. Does that make sense, Tendai? Cool, brilliant. Okay, Amatle, you got a hand up, go for it.
Good evening, ma'am.
Good evening, Amatle.
I would just like to ask, why couldn't we use the quadratic formula as part of our answering for the question and then use the values that we get as our critical values and then just put those onto our number line?
Amatle, I suppose you can. I suppose you can. But what I would just be very careful of is just if you did use the quadratic formula, then when you write your answers, okay, make sure that you are telling whoever's marking your work that you know that those are your critical values, that is not the solution to the question.
Oh, okay.
Okay, so
yes.
You've got no problem. So you've got to say there, you are expected to say there. I know at my school in trials, they're very strict about this. And if the boys don't write that those are the critical values, they actually, at my school, they take marks away. So I just don't want any of you losing marks in finals unnecessarily just because you didn't write something. So make sure that you write there that those are the critical values. And then, of course, you can use a number line or you can draw a parabola. Okay, am I clear?
Okay, thank you.
All right, no problem. Okay. Yes, that is absolutely correct. That would be the right answer, Nhlanhla, because that's exactly what we're going to do next now. Okay, is that based off of our critical values, we're now going to write our answer. Okay, so when you draw the parabola, if you're drawing a parabola, they expect you to shade in the region that you are solving for. So the smaller number on the left, the bigger number on the right, and you're quite right, Nhlanhla, it's going to be between these two. So in maths, we write between like this, with the smaller number on the left and the bigger number on the right. And your inequality signs in an inequality like our answer always have to be pointing in that direction. You can't have them pointing in opposite directions. They're always going to be like that, because when we start reading this, it's so weird. When we start reading this, we actually start in the middle. We start with x and we say x is greater than or equal to -3 or smaller than or equal to 5/2. Okay, and that is your final solution. Okay, so when x is a number between -3 and 5/2, the output values on the parabola are negative. The graph has gone below the x-axis. Okay, is that making sense to everyone? All right, so in this particular, yes, good. Okay. So here they would have given you a mark on your factors, a mark on your critical values, and a mark on your answer. There generally isn't a mark on the diagram, but you are supposed to draw one. Okay. All right. Do you want me to answer the same question? I can do exactly the same question with the inequality sign the other way around, and then I can show you what happens. Can I do that with you guys quickly? Is that all right? Yes. Okay. All right, cool. Okay, so now we're pretending. Let's just move this out the way. Oh, good. Okay, you're all saying yes. All right, good. Okay, so if the question was now instead, let's do this in a different color. Let's pretend the question was 2x squared plus x minus 15 is greater than or equal to 0. Now the question is for which values of x is y 0 or positive? You would follow exactly the same first steps. So in other words, factorizing to get your critical values. So we already know that our factors are 2x minus 5 times x plus 3 is greater than or equal to 0. And we also already know that our critical values are when x is equal to 5/2 or when x is equal to -3. Remember, our parabola is happy-faced. There is our x-axis. Smaller number on the left, bigger number on the right. Now, where is y positive? Y is positive above the x-axis. So instead of shading between, you are now shading over here or over there. That's the difference. Okay. Now your solution is no longer between two values. Okay, so you can't use this way of setting it out, because this way over here, this is specifically for when it is in between. Can we ever shade it in between? Yes, so we did in the previous question. Okay, Gugu, so what's on the screen now at the moment in blue was when we shaded in between. Okay, and that's what gave us that particular solution. Okay, because it was between. Oh, can you? Yes, you could, but then, Gugu, your parabola would be a sad face. So you can have that situation as well. So if you had a sad face parabola and they asked you for which values of x is y positive, then you would do it that way. You get it now. Okay. Then if if it was a sad face parabola and then they were asking you for which values is it negative, then you'd be shading over here where the blue is. Does that make sense now? Okay, you also get it. Okay. That's what's cool about these sorts of sessions, you know what I mean? Because we really kind of get back to a lot of basics that maybe you understood when your teacher taught you at the time, or maybe you didn't, and maybe a lot of time has gone by, and now looking at it with fresh eyes again, with the more experience that you've had going through grade 11 and matric, it starts to make a bit more sense. Cool. I'm so glad. That's awesome. That's brilliant. Cool. Okay, so just getting back to what the solution would be, okay, we cannot set it out like we did up here where I've got the blue circle around it, because that notation, that writing it in that form with x in the middle and the smaller number on the left and the bigger number on the right, is reserved strictly for when your answer is between two numbers. in a situation like the orange over here, it's it's here and smaller. Remember, X gets smaller to the left and bigger to the right. So if I'm shading over here, I'm talking about numbers going in that direction. That's where I'm shading. I'm going in this direction. Oh, I'm going in this direction over here. So that's why this will be where X is smaller than or equal to -3, or where X is greater than or equal to 5/2. Okay, so then you cannot write it as a between. You have to say smaller than the smallest x-intercept or bigger than the bigger x-intercept. Does that make sense to everybody? No, you can't. You can't use the word and. All right, so let's just talk about that a little bit, Gugu, because yes, you can do that, Nwazi. You can use interval notation, and I will write that for both as well. Okay. So Gugu, I just want to address what Gugu has said, because pleasure, Nwazi. Because it's very important. So when you are solving simultaneously, do you see here how they use the word and? Okay, so in maths, certain words have a very specific meaning attached to them. So for example, if I say in everyday language that if I was to say something like the temperature is increasing, you'd all interpret what I'm saying as it's getting hotter, the temperature is rising in value. Whereas in maths, when I talk about a function increasing, yes, I suppose it does mean it's going up, but it specifically means that the gradient is positive. So when X is positive, Y is positive. Right? So the words like increasing and decreasing, they have normal meanings attached to them in everyday English. But when we use it in a mathematical sense, it's got a very specific meaning attached to it. And it's the same with the words and or. Okay, so when we use the word and in maths, we mean two things at the same time, both at the same time. So for example, Gugu, you are a, maybe, I hope this isn't offensive to anybody who's gender specific or anything, but maybe I'll use Yolanda. Let me use Yolanda as an example, okay? Yolanda is a female and she is a teacher's assistant. So she's both at the same time. When you use the word or, it means you are one or it could be the other. So in other words, when we are finding a solution to a quadratic, we can't say x is 3,16 and x is -0,16, because it can't be both solutions are not valid at the same time. Either the one solution makes the equation the left equal the right, or the other one does. It's not both at the same time. Okay, so if you are solving simultaneously, Gugu, you can say x is 3 and y is 5, because x is equal to 3 and y is equal to 5 at the same time. So when it's solutions for the same variable, it's got to be the word or. When it's solutions for two different variables, then it can be and. Okay, so x is 3 and y is 5. Or you could say something like x is 2 or x is 3, y is 5 or y is -7. Does that make more sense? Yeah. So either it needs to be, yes, I understand that, Gugu. So either x needs to be smaller than or equal to -3 or greater than or equal to 5/2. Okay. Yeah, so when you're solving for the same variable, never the word and. Sorry, I kind of tend to go off on a tangent. All maths teachers, I think, are like that. You know, you ask a question and you get the answer plus a whole bunch of other stuff that you probably didn't want. Okay, so the point that I'm trying to make here is that when your answer is between, you can write it how I wrote it over here with the X in the middle and the smaller number on the left and the bigger number on the right. Okay. The alternative way of writing it is, as Nolwazi had suggested, I think it was you, Nolwazi, where you could use brackets. So then you would do that, but it means exactly the same thing. Okay, here you'd have to do a union of sets. So as you were saying, Nolwazi, you would go X is an element and then round bracket, negative infinity up to -3, square bracket, union, square bracket, 5/2 up to positive infinity, round bracket. Okay, so it means the same thing. It's just a different way of setting it out. Okay, I personally prefer the inequality notation, the set builder notation. I think that trying to remember the brackets on top of everything else is a little bit more challenging, but if that's what works for you and that's what you've always done, by all means, use the brackets. Okay. Any questions before I move on? Is this making more sense now? Do you feel a bit better about it? Cool. Lovely. Awesome. I'm so pleased. Yes, good. Okay, so this, good, Lebogang. Pleased to see that. Okay, so question number 2 is a little bit of a mean one. We've only got about 6 minutes, 6 minutes left. So we're going to have to, well, it's not a mean one now, looking at it a little bit more carefully. We're going to have to get a move on here. Right. So now what I've noticed in this particular question, all right, is that both the y and the x terms have coefficients that are not 1. So normally if we had an equation like, let's say we had 2x, no, not plus, let's say 2x minus y is equal to 1. What we would normally do is we would choose to make the y the subject of the formula rather than the x, because we don't want to work with fractions. So we would transpose the y, transpose the 1, and then we would go and sub in. In this case over here, they've actually been a little bit nicer to us. We don't have to work with fractions. No, you can't use elimination here because the second equation is quadratic. So elimination can only be used, Lebogang, when both equations are linear equations. And the reason for that is because it's like terms. So whilst you could line up the y terms, it's fine, but you can't say 3x minus x squared. Okay, so you could divide by 2, but if you have a look here, they've given you what 2y is equal to, and then they've put 2y over there. Do you see that? So instead of you having to divide through by 2, if they didn't have 2y here and they had 3y, or they had 4y, or they had 1y, then you would divide through by 2. But here you can actually just go and straight substitute it in there. Okay, so because it's 2y, so plus, and 2y was equal to 3x plus 1 is equal to 29. Does that make sense to everybody? Yeah, I mean, your other option here, I'm sure your answers will still be correct. Okay, so we'd end up with x squared plus 3x, and then I'm going to move this over and we'd end up with -28 equals 0. Does that make sense to everybody? And then we'd factorize or use the quadratic formula, up to you. And now, gosh, 7 and 4, hey, so we'd have to have plus 7 and minus 4. So either x is equal to -7 or x is equal to 4. Did you guys have the same answer? Yeah. So Mamelo, that's often the case in maths. You know, have a look at something carefully first before you jump in. The only thing, I know you want to do the poll. Sorry, Yolanda, we just need to do the solutions for y. And then,
That's okay.
and then we can do the poll. Okay, so 2y is equal to 3 times -7 plus 1. So that would be 2y is equal to -21 plus 1. So 2y would be equal to -20, so y would be equal to -10, or, whoopsie, sorry, I'm squashing it in here, everybody, or, sorry, 2y is equal to 3 times 4 plus 1. Is that correct? Yes, so 2y would be equal to 13, so y would be equal to 13 over 2. That's it, or 13 over 2, quite right. Okay, so 6 marks, sorry, just very quickly, subbing in factors or quadratic formula, both solutions for x, both solutions for y, or maybe what they did is gave you 1, 2, 3, 4, 5, 6. There we go. All right, I'm done.